Hello and welcome back to another episode of All Around Azure. My name is Jason Hand, back again with you. Really excited for today's guest and topic. It's a good friend of mine that we've been doing a lot of fun stuff in the past year or two, going around the world with the Ignite Tour. And the guy just knows a ton of stuff, and it's always fun to hang out with him. But let's go ahead and introduce him and bring him on here and learn a little bit more about my good friend, Neil Peterson. Hi, Neil. How are you?
Hey, Jason, how's it going? I'm good, thanks.
Good. Really glad to have you on the show. Can you hear me okay?
I can. There's an echo
There's an echo?
on my end.
Maybe check if you have the playback screen from the Twitch channel. See if that's maybe one of them.
I'm just gonna go ahead and close that down. Yeah, I think that took care of it.
Cool. And let me get rid of some of the extra noises on my end. But how you been, man? I haven't seen you forever. We've kind of been shifting around. We were doing all kinds of work together, and then boom, things changed. What's new?
Yeah, no, I've been good. We did the Ignite tour together, and I decided to try out my hat PMing a product for a while, which was fun, but ultimately. I couldn't stay away from DevRel. I wanted to get back into doing some engineering and playing around with code and stuff. So I'm back. I'm back in DevRel, working on the patterns and practices team, where we build, kind of like production-ready guidance.
Mm-hmm.
Just started a couple weeks ago, so just kind of getting my feet wet. But yeah, definitely happy to be working back with the DevRel team.
Yeah, and we're excited to have you back and be able to do stuff like this again. I think I reached out to you a while ago with this idea, and you were still on the ARMS tools team, or you're working on some ARMS tools, and timing wise, it just wasn't going to work out. But now you're back with the community people working on stuff like this. So really excited to make this happen. So.
Yeah, cool.
Why don't you maybe give us a little bit of a run through on some of the stuff we're going to go over today in the 90 minutes that we have, and we'll go from there.
Yeah, so I think the scenario that I'll set up is I've got an app, just a simple little Hello World app written in ASP.NET, and I want to run this app in Kubernetes, Azure Kubernetes Service specifically. However, this app has a requirement to pull secrets from Key Vault. So we're going to look at a couple different ways in which we can host apps in an AKS cluster and reach out to Key Vault rather, grab secrets, pull those into the app, and then do things with them. And this came from a project that I was on recently, where essentially I was given an app, and the ask was get this running in Kubernetes, and the SQL server connection strings and passwords are stored in Key Vault, and we need to suck those in so that the app can make the connection to the database.
Yeah.
So I've got two different methods that we're going to look at. One is specific to ASP.NET. The other one is more generalized, and there's a bunch of Azure going on in here. We're going to see things like, okay, I've got the app running in Kubernetes, but how does it authenticate? How does it gain that access to the Key Vault to pull those secrets? So we're going to look at something called pod identity, which is integrated with Azure Active Directory. Should be a lot of fun.
There's a lot of buzzwords in there too, and I imagine some of them might be new to some of the folks on the stream, but we'll try to keep up and make sure we, especially with any acronyms like AKS, Azure's Kubernetes Services, even Kubernetes in general. Do you want to maybe give us just a little bit of what is Kubernetes? Like, what's the elevator pitch behind that, and some containers and all that kind of thing?
Yeah, it's a huge space. I'll kind of do my best, for my peer review. But so Azure Kubernetes Service is a Kubernetes implementation on Azure, and some of the value of Kubernetes, containers are getting big. We got Docker containers, which allow you to kind of package up code. And that code becomes very portable. I can run the container image on my system and then push it to something like a Kubernetes cluster and run it in Kubernetes. And kind of one of the value propositions there is that it is portable. All of the dependencies are packaged up inside of that container image, so I don't have to do things like make sure that I've got the right dependencies, packages, libraries on my local system and in my Kubernetes cluster. I just kind of ship all of that around with the container image. Now, Kubernetes then takes kind of running containers or container images a little bit further, and it provides orchestration around those. So a Kubernetes cluster might have multiple different nodes or virtual machines or physical machines or whatever it may be, excuse me, where we can run these containers. And one of the things Kubernetes does is it kind of has the responsibility of making sure that that container gets scheduled on one of those nodes. If one of the nodes fails, it will, recognize that and move the container to another node. So it really manages kind of like the uptime and the availability of the applications that are running on top of it. And actually, we'll see a little bit of that today. We're going to actually like crash a container, and we'll see Kubernetes like recreate it, just a way to kind of reload some secrets into it. So we'll see kind of some of the, even though we're not going to really talk about the benefits of Kubernetes, we'll see some of those benefits throughout the demonstration.
Okay, cool. Yeah. And I feel like, just not just Kubernetes, but actually I had a question or something that reminded me, you reminded me of a thing I wanted to ask you earlier is, do you recall, I'm sure we could look this up, was it around 2014, 2015 when Kubernetes came out in general to the general public? It's not been around that long, right?
It sounds about right, but I don't know exactly. But yeah, it's a pretty young piece of technology, but it's definitely, like you said, it's a buzzword. Lots of people are talking about it. Lots of people want to be involved, and
right.
it's really growing legs and taking off from my perspective.
And we've got some like true experts who have been at the heart of Kubernetes working at Microsoft too, right? Like, even though it's an open source type of where it came from, like it's used all over the place, lots of contributors. But even at Microsoft, we've got some of the like early people that were developing it, right?
Yeah. So Brendan Burns is over at Microsoft. There was the Deis team came over, so Gabe Monroy. So yeah, there's a lot of kind of day one institutionalized knowledge at Microsoft around Kubernetes.
Yeah, it's a pretty powerful piece of technology. But I think also a lot of people realize that it's not something you use just because you want to use it. It's a specific tool to solve a specific problem, and especially around scaling and having these large distributed systems.
Yeah.
So really exciting stuff.
Yeah, it's pretty funny. You brought up like, it doesn't fit all use cases. There's kind of a funny meme that you might run into every once in a while where it's like, oh, I have my blog running on a Kubernetes cluster. It's just kind of like, it's a lot to run a lot of small things, but it is the exciting thing, and a lot of people want to be involved.
Yeah. We've got somebody in our chat giving us a little bit of a history. It says it was an internal project with Google called Borg, which I remember that. Yeah. And then it became publicly known as Kubernetes when Google gave it to the CNCF. Microsoft jumped on it to extend it for their use with the AKS.
Yep.
Which sounds about right. And I was trying to remember the year solely because it was at OzCon in Austin, Texas, and I was there. I think it was my first year like doing DevRel, and I remember I met Ashley McNamara, who's on our team there for the first time, and a bunch of other people who are now best friends and even coworkers. So I don't know, for some reason being at that OzCon, that was my first OzCon ever, the open source conference, and it was a really weird and awesome experience that I'll never forget, except I don't remember the year. I'll have to go back and look exactly what it was.
And my history with it is that, I came to the Seattle area from Houston, where I was working in an organization called PFE. And I moved into DevRel at that point, or what is now known as DevRel. And I wrote the initial set of documentation around AKS. And in that point, or at that time, I just kind of, it really excited me. It was actually like some of the most fun I'd had with technology since like I learned PowerShell. Just really kind of, I didn't have any good use cases for it, but it was a lot of fun to work with and play with, and really kind of conceptualize how it could change industries and things like that.
Totally. Yeah. That's when because you kind of got me up to speed on actual using it last year. Like I'd never had a use case for it. And of course I, kind of read through the docs, but there was no reason for me to play around with it too much. And then last year when we were putting together the content for the tour, and we're trying to make it so that we can basically take down an entire system, create a simulated problem so that we could do some of the other stuff. I got a bug like flying around my face. The way we decided to do it is the whole system's built on Kubernetes. So we're just going to crash a pod and go from there. So that's where you're the person who taught me Kubernetes. So I'm glad to bring you back, and you can help teach all the others out there more about it too.
So it's a funny thing. I actually spent last night trying to redeploy that Talon Traders system from Ignite Tour. Needs a little bit of work, and it's kind of outdated, but it's funny how these things kind of come together.
Totally.
I'll address one thing to your point, though. Yeah, it is pretty new, and we're actually going to look at how you deploy stuff into Kubernetes kind of at depth. And there's a lot of, new foreign concepts there if you haven't worked with Kubernetes. And I'll take my time to kind of walk through them and relate what they are to kind of practical, like what's practically going on inside of the cluster. So I think we should be able to do this in a way that, if it's your first time seeing Kubernetes, you'll see the value in Kubernetes, some of the capabilities of Kubernetes, but then also see specifically what we're here to talk about, which is accessing Key Vault from the Kubernetes cluster. So I'll really try. And if at any point I get into something that needs more clarification, just let us know, Jason. I actually closed down the window because of that echo, so I'll just rely on you to.
I'll keep an eye on the chat. So we've already got Code with Sean. Thanks for the questions and the background and everything too. So keep the questions coming, and don't feel free to jump in too with anything else relevant. So we like to keep this very conversational with not just Neil and I, but everybody else. So and for those of you who are watching us over on Learn TV, welcome. Glad to have you here. If you'd like to join in on the conversation, we're over at the Microsoft Developer Twitch channel. So go find us at twitch.tv/Microsoft Developer. I can't talk. And we'll chat with you over there. Should we switch over to your machine, Neil, and start taking a look at some stuff? Show us what you want to go through.
Yeah. So, going to be kind of informal here and just kind of walk through a bunch of stuff and just really play with some tech.
Yeah, let's do it.
All right, cool. Let me know.
So we're looking at we got your Key Vault demos screen here, VS Code.
All right, cool. So like I said, I've got a small app, just a little Hello World app in this case. And let's just go ahead and take a look at the app like running locally. So I'm just going to run .NET run, which should just start up a Kestrel server and host my app. And I will, I'll go ahead and say I don't have a whole lot of background in application development. This is much more about the infrastructure and like access, but we'll see a little bit of the code here as well. So that is running locally. So let me go ahead and see. And so we've got just this little simple application. It just says welcome. Now there's actually another line of text here. Right now it's blank, and this is the values that we're ultimately going to pull from Kubernetes. But let's go ahead and just get that running locally. So I'm going to go back over to the app. Close it down. I'm going to come into my app settings.json. And so I've got this value in here, KV secret. And what we have here, I'm actually going to pop over to my README really quickly. So .NET has this thing called Configuration Manager, which is, from my understanding, my limited understanding, is a way to populate data using things like in-memory .NET objects, environment variables, this system built into .NET called Secret Manager Storage, and then finally Key Vault. So these different places in which we can pull data. And the cool thing about it is that, if my app is expecting a value to come from I can provide that value through an environment variable or app settings.ini file or Key Vault. So I can bring data into my app from multiple different places without having to modify my code. And it's this configuration manager that manages that. So you just have this system looking for this data in these multiple different places, and then we'll take that and then use that within the app. So that's kind of what we're looking at here. And you can see I pulled this up just to kind of remind me during this conversation, there is a set of precedents that Configuration Manager will look for.
Okay.
So if I have the data or a piece of data specified in an environment variable and also in Key Vault, and my app is accessing, has access to both of those, it's gonna, it's gonna choose the Key Vault value over the environment variable value.
Okay.
We may or may not see this in the demonstration, but I wanted to call out kind of like the back end of where this stuff is coming from. So I'm going to go back over to my app settings.json file and just put some information in here. So hello from app settings.json. I'll go ahead and save that and rerun my application. And let's just go see what it looks like now. All right, so we can see now I've got this information here.
Okay, cool.
Hello from appsettings.json. Cool. So we've got an app running locally. I want to move this to Kubernetes. And instead of pulling this value from the application itself in appsettings.json file, I want to pull it from Key Vault. So let's see how we're going to do that.
So Key Vault it's for secrets.
Yep.
But secrets can be a lot of things.
Yep.
So I've yet to actually have a project where I've used Key Vault. Is it like just mostly for passwords, or like what else can we use it for?
You can store. Actually, let's just take a look.
Okay.
All right. So right here, I'm in the Azure portal, and this is the Key Vault instance that we're going to be working against. So I'll go ahead and click on that. And you can see over here under settings, we can see a list of the things that I can store in here. So keys, secrets, certificates.
Okay.
Specifically now, if I go under secrets, we can see that I have a Key Vault secret in here called KV secret. And I'll drill in on this. And I've got my secret in here. I can actually, let's see, there's a way. Yep, show secret value. And we can see that in this case, my secret is hello world from Key Vault. Now, going back to the project that I was working on that kind of led me into this tech, we stored things like connection string to an Azure SQL database and the password. So again, we were still using secrets, but I think, like a primary or like a good use case is things like connection strings, passwords, but you can store certificates and other things in here as well.
Okay, cool. Yeah, and we've got just a I guess comment from Code with Sean. He's excited to see this integration with AKV, but I'm also curious about an integration with Azure App Configuration Service. Does that ring any bells?
Yeah, so I know, that's funny that we brought that up. Had I had more time, I wanted to look at that. So app configure is...
How many times a day do you find yourself saying that? Because it's exactly, at least 4 or 5 for me, yeah.
Exactly. But it did, it did occur to me that there is something missing from this conversation, and that is app configuration. I don't know a whole lot about app configuration. What I do know is it is like kind of like the app settings.ini file that we just saw, but hosted in Azure. So a centralized place where I can manage the configurations of my applications that then get pushed down to them. That's about as comfortable as I am with the technology. And I will, I'll also say that we're going to look at 2 methods for bringing secrets into an application running in AKS, Azure Kubernetes Service. I would imagine there are more app configuration and potentially others as well. But good call out. I think great minds think alike. Coming into this, I was like, man, I wish I could get that in here as well, because I do think there is something there, and it's something that I'd be interested in learning more about as well.
Cool. Well, maybe we can do a follow-up show.
That'd be fun. Road. Send me away with some homework.
Yeah, once we both had that actual time to sit down and explore. I need like a good just week solid of just R&D and catch up time, and man,
I know it'd be great.
Just avoid my inbox.
All right, cool. Well, so yeah, let's look at the first method here, and this one is specific to .NET, ASP.NET Core. So we've got this thing called the Azure Key Vault Configuration Provider, and what this is it's just a library for .NET that is built for the purpose of accessing Key Vault secrets. So I actually instrument my code to access Key Vault. And we can go ahead and take a look at that. This is the kind of where, I get a little bit outside of my comfort zone. So I won't go through like every line of the code.
Okay. So no hard questions for the next few minutes?
Hey, I'll try them. I'll take them, and we can definitely come back to them if we need to. But definitely, like my focus is more on the operational aspects.
Right.
But so just in a couple different lines of code, we have basically instrumented this app so that it's going to attempt to connect to a Key Vault, which we can see down here. We provide the Key Vault name as an environment variable. And then it's going to load the secrets that are stored in that Key Vault into the .NET environment. So we've essentially used this library to instrument this application to access Key Vault.
Okay.
So again, very, very specific to .NET. Now, but there's more to it than that, and we'll kind of work our way into. Okay, we've got an instrumented app. But like, what about access control? Like, how does that app, like Key Vault, we're storing potentially very sensitive things there. Certainly, I can't just instrument this app and it has untethered access to the Key Vault. So what are the other things that we need to be put into place? So let's do this. I think what we'll do is just walk through the pieces that we're going to deploy into Kubernetes. And again, I'll talk through each of them. We'll deploy it and take a look. So I'm using Helm charts to deploy my applications into Kubernetes. I guess we'll talk about how you get things into Kubernetes. Like, how do I actually put something into Kubernetes? And there's a couple different ways. Kind of the most native way is to use what's called a Kubernetes manifest file, which is a YAML file that defines all of the objects that you're going to put into Kubernetes. Kubernetes is built on the system of objects. Like, everything is an object within the Kubernetes cluster, or from the vantage point of the Kubernetes API services. And a manifest file is just like a declarative way to state what all of those objects are. Kind of some of the common types of objects that you might put into Kubernetes. One is called a pod, and a pod is just the thing inside of Kubernetes that runs the container images. A pod can contain one or more containers. Another example would be a service, which is an endpoint in which you would access something or a pod inside of Kubernetes. And you define all of these things in a manifest file, which is just a YAML file. Helm kind of extends the capability of what you can do in authoring those manifest files, because a Kubernetes manifest file is just a YAML file. You can't do things like add conditions, like if this condition exists, add this pod. Helm gives us that capability. So it really just extends the capability of the manifest file, allowing us to add conditions. And most importantly for this conversation, it allows us to template things in. So without getting in, we'll get into like what all of these are, but you can see right here, I've got this values.subscription ID. So Helm allows me to kind of like dynamically replace values inside of my Kubernetes manifest file, so that I can, in this case, generalize these manifest files and run them over and over and over again with different values to have different results. And that's the reason I'm using Helm here, is because I do want to run this over and over and over again. And rather than having to go into a manifest file, which would look very similar to this, but just have like string values, like rather than having to come in and update these, to my new environment, I can just use Helm to bring those values in kind of dynamically at runtime. So that's Helm. So what we're looking at here is a Helm chart. There's a couple other pieces like metadata and stuff that goes along with the chart. But really the focus here is just what's going on inside of this. All right, so we've got an app. We want to get secrets from Key Vault. We've talked about Helm. We're going to use a Helm chart to put our app into the AKS cluster. So let's talk about all the things that are going on inside of this manifest file, which will kind of lead us to like, how does this app have access to that key vault?
Excellent, excellent. Hey, real quick, exciting news. We just had some more people join us on the stream because the Visual Studio gang just raided us with all of their folks. So welcome everybody coming over from Visual Studio. Glad to have you. This is All Around Azure. This is my good friend Neil Peterson, and we are talking about Kubernetes on Azure. So glad to have you here. If you got questions, feel free to drop those in the chat. We'd love to talk to you. And yeah, Neil, I'll let you get back to it. Just want to say hi.
Yep. Thanks for joining. Okay, so the first topic at hand is identity. So we've already established I've got this .NET library that's going to allow me to instrument my application to access Key Vault. But there's a key missing piece there, and that is the access. And for this, we're going to use an Azure managed identity. So a managed identity is just it's like an identity that you create within Azure that can then be assigned to resources. So we've had these things called service principals for quite some time. I can create a service principal, and it's really kind of like a username and password. But it was really up to me to manage how something uses that service principal. And a managed identity takes it kind of a step further, and it works, from my understanding, very similar to a service principal. However, I can assign it to things like a virtual machine or a virtual machine scale set. So now that VM in this instance, or even like a container instance, which is another service, Azure Container Instances is like the ability to run a container without having the Kubernetes cluster behind it. It's kind of just like a simple, I need a container. Like I can give that a managed identity, and you're really kind of elevating or giving those resource types an identity that can then be used to access other things within Azure. So let's go ahead. I'm going to flip over the portal into this resource group here. A resource group, again, or just to kind of call out all the technology, is just like a logical grouping of Azure resources. And we can see in here, I've got this managed identity object called AKS pod identity. So we've established an identity, and then we can use something called pod identity to give the nodes within our cluster or the pods within our cluster, like allow them to assume this identity.
Okay.
So now I've got an application, my .NET app. It's running on a node inside of that cluster, and it's assumed this identity that we've created. It's then that identity, that managed identity, we're going to give access to the Key Vault, and boom, we've kind of made that connection. In fact, I'm flipping back and forth here. I apologize for that.
No, that's great.
Hope that's okay. But let's actually go see that. So we can see I've got okay.
Looks like we might have lost our connection with Neil there for a moment.
Pod identity of Kubernetes, or I'm sorry, out of Key Vault. All right, so that's kind of the secret sauce that gives us that authentication to Key Vault. So now let's walk through this manifest file or this Helm chart here and see how it all works.
So Neil, I need to pause you just for a second because I'm giggling just a little bit at chat, and also because one of us had a network, some bandwidth issues there for a second, so you got frozen, and then all of your audio came through like a million miles an hour. So maybe just give us like the last 10 seconds or the highlights of what you just said.
Yeah. So again, we've got an app. It's instrumented to access Key Vault. What is the identity mechanism? For that, we use a managed identity, which just a managed identity we can assign to a resource within Azure. In this case, we've got this AKS pod identity. We can see it's a managed identity. And then if we click in on the Key Vault and look at access policies, we can see that I've given that specific managed identity access to get and list secrets from the Key Vault.
Okay.
So it's that identity that we're going to use. And let's just actually flip over and see exactly how we use that.
Great.
All right, so now we're going to walk through this manifest file, or this Helm chart in this case. And there is a lot going on in here. And I'll just kind of walk through it and just kind of use human terms to try to land the concepts. And these are all the objects that we're going to need to deploy into the cluster to have this application run and access the Key Vault. Now, kind of in a production world, I may have a lot of this already stood up. So some of the identity stuff might just be running in my cluster, and then I would deploy my app and it would consume some of that stuff. For the case of this demo, I just put it all into one manifest file, just to kind of simplify the deployment process and the demonstration process. It does unfortunately cause a little bit of delay when you deploy stuff, but we can work through that. All right, so this is just a YAML with a little bit of Helm kind of templating going on inside of it, and kind of where you delineate objects, because there are a bunch of objects we're going to deploy, is kind of these 3 dashes. So anytime you see 3 dashes, that's kind of like the break between one object and the next object.
Okay.
All right, so the first one here is an Azure identity. Pod identity in an AKS cluster is something that you do have to configure and get stood up. I believe I've given you docs on how to do that. So you deploy the cluster and you make sure that it is lit up to consume this object type, Azure identity. In other words, Azure identity is not an object that's native to Kubernetes. Earlier, we were talking about some of the benefits of Kubernetes. Mm-hmm. One of the other things that Kubernetes does fabulously well is it's super duper extensible. The API, if you go and look at some of information from some of the people that were involved very early on, this was a very early tenet that Kubernetes should have this super duper extensible API, and it should be simple to do. So you can build your own custom things and objects that you can put into a Kubernetes cluster, and that's what we're looking at here. So anytime you see kind, this is the kind of object that we're going to deploy into the cluster. And essentially, it's just a bunch of metadata. And then there is a controller or a piece of compiled code running inside of the cluster, looking for any instance of this object. It will then take the data from the object and then do something with it. So in this case, we're creating an object called Azure Identity. And essentially what this object does is it just stores the resource ID of the managed identity that we've created, and then the client ID, which is essentially the username. So the first thing that we're doing here is creating an Azure identity inside of this cluster. And now that identity will exist, and I can use it across several different places. So Azure identity, just a representation of that managed identity in the cluster. Mm-hmm. Mm-hmm. The next thing we're going to do is create an Azure identity binding. And this is the intent to use that identity. And how this is configured is we basically specify this thing called a selector. Another thing about Kubernetes is it relies heavily on labeling stuff. So if I deploy a pod that has an app running in it, and then I deploy a service, which we talked about is kind of like an endpoint, is something that I would access. I would actually access the service, which would pass traffic to my pod. The way we bind these two things together is through a labeling system. So if any pod that has label X, forward this traffic to them. And it's the same thing here. So we've got this Azure identity binding. We've got a selector. We provided a value. And what we're saying is that any pod that has a label that matches this, go ahead and use this identity. So we have this way to kind of selectively choose which pods do and do not use these identities. Mm-hmm. I'll kind of jump ahead here, but you can see I've highlighted this. We'll go through this, but you can see here in this deployment, which I'll explain what it is, we have this metadata of AAD pod ID binding, which we're templating data in here, we're using Helm to kind of dynamically provide values. You can see these two match right here. Mm-hmm. And that's that key. So when I start this deployment, which I'll talk about, we've got that label or metadata configuration that indicates like, oh, hey, I should engage this pod identity system, and I need to kind of assume that identity, which we'll look at some logs and kind of see that work.
Okay.
All right, so we've created an identity, or we've defined an identity, which again has all the data that binds it to that managed identity that we looked at in the portal. We've defined the binding, which again is really just an intent to use an identity. Now let's actually look at the actual application. So we've talked about pods, which is just a way to run a container image or multiple container images in the cluster. But here we're deploying something called a deployment, or we're defining something called a deployment. This is kind of like an abstraction on top of pods that provides a little more. It creates a couple different object types. One is called a replica set. And we talked earlier about like if a node fails, Kubernetes will recognize that and move our workload somewhere else. It's this deployment object that kind of gives us those capabilities. I won't go too far into it, but it's really just kind of like it's like pod plus plus plus. It's like, you want to run some pods, but you also want to make sure they're running. Right. And you want to be able to do things like specify how many replicas you want. So the deployment really gives us like that ability to not only deploy container images, but keep them running and scale them. So it provides like, just think of like the pod as like the most simple, small unit of running an application. And the deployment extends our ability to like keep it running and scale it in and out and stuff.
Yeah.
So we're defining a deployment. We've got some metadata in here, or we've got some specifications, like how many replicas do we want of it running. We've got the metadata. Let's see. We've got our AAD pod.
One of the other things, sorry, Neil, one of the other things I just thought of is when we were talking, when you were kind of, getting me up to speed on all this stuff last year, and we were talking about how can we cause a failure in the system, and I was just like, well, let's just delete something, and then I think you were like, no, that is just going to come back. Like that's what this thing does. Like you can do whatever you want to it, but it's just going to come back.
Yeah.
Which is the whole point, is like they kind of self-monitor and as needed make changes.
Yeah, it's pretty cool. Yeah, and like I said, so when you create a deployment, you're actually creating a deployment object, and under that you've got your pods, and then you've got something called a replica set, and it's that replica set, and you can create all these things independently, but using a deployment just kind of bundles it all up, and makes it a little simple to do. And it's really that replica set that kind of watches things and keeps things in the state that you define here in this deployment object.
Even down to the ports that are being used or not used and all that. Yeah.
Yep. Absolutely. All right. So we've got that selector identified. So basically, again, these are like, we're dynamically providing information, but these values will match, which indicates, okay, I need to bind or use this managed identity. And at that, once we use it, we're basically just saying like, hey, these pods assume this identity. They've got access to Key Vault in the way that we've configured it. We then get into like the actual workload that we're spinning up. So we've got this spec, which really this spec here is the pod. Like, what are the things, like what container image do we want to run? What are the resource requirements, ports? And then we can specify things like environment variables. So when we were looking at the application, I mentioned that we were bringing over the Key Vault name as an environment variable. So we are going to pass to it one environment variable, which is the Key Vault, so it knows where to go.
Okay.
The rest of this stuff, I'm not going to dig into too much. It's really not part of the demo, but I'll go ahead and just, since we're here, call out some cool things.
Yeah, I was going to say, we had Bruno Borges on last week, and he like promised me he was going to go on this whole spiel about YAML. And it was like, how much fun can we have just talking about YAML all day? This is great.
I get it, and I'll zoom through this stuff. So the other things that I'm defining here, because there is actually some pretty cool stuff in here.
Yeah, it's fascinating.
We're using some other really cool concepts.
No, I don't want you to speed through it. I just think it's funny. The debates about YAML is like, this is the world we live in now. We just deal with YAML files.
Yeah, I'm well aware of Bruno's opinion.
Yeah.
So the other things, I've got a service. So this is really just creating an endpoint in which we can talk to the pod that's running. The other thing is I've got an ingress controller running in this cluster. So we can AKS can like plumb through an Azure load balancer, meaning expose an app to the internet using public IP addresses. In this particular case, I've got what's called an ingress controller running inside of my cluster. And it allows me to do things like specify paths. So using a single IP address, I can say like, hey, if you're on this path, route to this service. Mm-hmm. If you're on this path, route to this service. So it just gives me kind of some like internal routing logic, load balancing without having to have multiple exposed IP addresses. And then finally, I've got I've integrated something called Cert Manager. So when I start this application, and this is kind of where some of the startup delay is, it will actually dynamically go out to Let's Encrypt, grab a certificate, and configure it all up so that my application is secure.
Wow.
So that was a lot.
Yeah.
Let's go ahead and see this thing run. So I actually used Terraform to deploy this. And one of the things that I did was I specified some output on my Terraform configuration so that I didn't have to like manually type all the commands. Mm-hmm. All right, that's what I'm pulling up right now. It looks pretty messy, but let me just pull this out, clear my screen, and then we'll look at the command specifically. So I'm just doing a Helm install, which will install the chart. And then for all of these, like where you see like .value subscription ID, mm-hmm. all I'm really doing is passing in those values on the command line. So there's a lot of stuff here, but really I'm just passing in values that I need to consume. All right, so I will go ahead and run that. Some other little things are like I'm pulling my container image from Azure Container Registry.
Hey, we've got a question in chat.
Yep.
With regards to the Let's Encrypt little black magic thing there.
Yep.
Do you know if it has automatic renewal for those certifications? I don't think it does.
I don't know, but I know if you just look up Cert Manager, I mean, it's a pretty active project. So right here, Kubernetes Cert Manager, and I think the docs should explain that pretty quickly.
Okay, cool.
All right, cool. So appreciate it. And I apologize, I don't know more about that. So I just ran the command kgp. I have some aliases set up. So that's actually kubectl get pods to return a list of everything running in my cluster. With a Kubernetes cluster, you can break things down into namespaces. So I can create a namespace for JSON, and JSON stuff would be running in that namespace. I'm not messing around with any of that for the demonstration. So everything's running in the default namespace. So there is a lot of stuff running here. And a lot of it is kind of like some of the helper processes, like the managed identity stuff is right here. And we could potentially put those in isolated namespaces so that you're kind of not seeing it here in the default, just calling out kind of why there's so much here. And then let's just look at one thing real quick before we look at the app. And that is the managed identity process. So we did start this deployment, which matched the selector. So essentially it should have been assigned the managed identity. These two pods right here, so MIC stands for Managed Identity Controller. And this is the logic that's kind of like looking for all of this. And if it sees like, okay, I see that selector value is matches, we need to go ahead and do some work and make sure that the managed identity is set up. So we can actually do kube logs. Now there's two replicas, so I'm going to have to kind of guess which one is doing the work, or like which one is the leader right now. Mm-hmm. So I'm doing kubectl, which I've got an alias, logs, and then the first pod there. And it does not look like it was that one. So let me grab the second one. And you'll see what we're doing here. Yeah, right here. So we can actually see in the logs that it did register, like, yep, updating user assigned identities on AKS default VMSS. So this is actually the VM scale set that is running the nodes that are behind the cluster. So a VM scale set, I don't know a whole lot about them, but it's like a way to have identically configured virtual machines that you can then scale in and out. So using a VM scale set behind an AKS cluster, you can do things like, hey, we're running, very simple, kind of like the canonical example. We're running into a holiday season and we need more power behind our cluster, so let's scale this thing out.
Yeah.
And then you can see that it has assigned the identity. So just kind of looking, peeking behind the scenes, we can see that things are actually working here.
Is this where the Let's Encrypt stuff is happening too? Is there a log for that?
Yeah, there is.
And we got a question in this is probably a question about the YAML in chat about how are we passing the domain name to generate the certificate? Or is that?
Yeah. That was during deployment. If we want to see that. Let's see, where did I? I set that up at one point and I haven't revisited it at any point. But so I have these Terraform configurations that deploy everything, and I believe it was during that process.
Okay.
All right. Let's see here. All right, so we've deployed everything. We saw that the managed identity was assigned. Just to make sure everything is good before we start jumping into demonstration, I'm going to pull the logs on the actual pod. So this pod right here is running our application. And it looks like it is running. All right. And so now I'm going to get the endpoint for my ingress controller. And so there is that domain.
Yep.
And let's pop over to Edge, drop that in there. And we can see, in fact, hello world from Key Vault.
Nice.
Now, when I packaged that application up into the container image, if you recall, when we were looking at the application, we had the settings file, and I had kind of put in there hello world from ASP.settings.ini. When I packaged that up, that value was blank. So it's actually pulling this from Key Vault. In fact, let's prove that out. And I'm going to go ahead and go into Key Vault and get this secret here. And I will update this. Actually, let me see. New version. And I will call this hello. Hello, Jason from Key Vault. Go ahead and create that, which is going to create a new version of that secret that's updated. I actually haven't tried this, so we're...
That's what these streams are for. Trying out demos for the first time.
When I prepped this demo, I actually deleted the secret and then reran things and saw that it was blank, but I want that secret there for later. Yeah. So we'll let's see how this works. Now, I do need to restart my pod to consume that. And again, this is something that Kubernetes does well as far as like rolling deployments and helping you update something with little downtime. In this case, that's not really of super important value for us. But rather than kind of like recreate everything, kind of going back to what we talked about before, how Kubernetes will keep stuff running for you, and if you delete it and you're using a deployment, it will just come back. That's what we're going to do. So I'm going to do kubectl.
We have some more guests joining us. We had another raid. Welcome all of our friends from the Crazy4Pi 314. group. Good to have you here. My name's Jason. This is Neil. We're talking about Kubernetes on Azure, among other things.
All right, so I'm deleting that pod now. And we can see that one is already rerunning. So that quickly, the replica set recognized like, hey, you said you want one replica of this thing, and there are none. I have none, so I'm going to go ahead and create a new one. And at that time, as the pod stood up, it would have gone through that whole process again. Assumed the managed identity, reached out to Key Vault, sucked in the secret, and we'll see how we did. Like I said, kind of ad hocing here live. Just make sure it's up and running, so it looks like it is running. Come back over here, and because we're using a service and an ingress controller, like how we access that pod, even though it's a totally new pod, doesn't change. The service kind of like abstracts. So we're going to hit that service. It's going to forward onto the new pod,
right?
Because the labels match. Go ahead and refresh this. Boom. And it worked.
Nice.
Okay.
The demo gods have shined on you positively. We've got a question in chat about the difference between, and I know you may not know this, but the difference between ASP.NET and Core. Do you know much about how to like define the differences between those two?
Yeah, I'm not.
Put you on
I'm
the
not.
spot.
I mean, I've got some generalized like ideas, but again, I'm not.
It seems to me. I mean, I don't know the exact. I'm sure we could look it up, the exact like breakdown differences, but seems to me more and more people are definitely moving towards Core.
Yeah, I mean, you know, the big thing is cross-platform, and being able to write .NET code for Linux, Mac, Windows, or whatnot. But I mean, I think it also, just general, smaller, faster, more capable across multiple different platforms.
Right.
As far as like technically what's different, like if I'm going to write
I think the language
versus a .NET Core, that's where my understanding kind of goes away.
And I would also just add that, excuse me, inside Azure, you get so much functionality just like right out of the gate. If you're using Core, specifically around monitoring, like if you want to put some application insights in there, monitor all the different things that are important to your users and to your application, to your business, whatever it is you're building. All that stuff, if you're using .core, it's just a matter of like checking a box inside Azure, and suddenly you've got all this stuff. So I think that's a big reason if you're trying to decide between one or the other. For me, it feels like Core is the way to go.
Yeah, I mean, again, I don't feel in a position to state this is the way to go, but as an outsider, it sure does seem like it.
Yeah.
I keep looking over here, Jason, because you are on this screen over here. So I apologize, dear.
I know I've got you all over the place there too.
Cool. So that was, okay. So we've got, ASP.NET Core app. We used a library specific to accessing Key Vault. However, there's a problem there, and that is that we're really limited to ASP.NET Core. Let's look at another way we can do this exact same thing, but is a little more generalized, and that we can use across multiple different languages. Before we do that, though, I need to clean up some stuff. So we used Helm to deploy all of these things into Kubernetes. I can do Helm list to see all of the Helm charts that I've deployed into my cluster. I'm just going to go ahead and delete one.
Okay.
Helm uninstall, and this is the one that we just deployed. And then it's going to go remove all of those things. I think for this next demo, this one does take a little bit to run. I'm going to run it and then talk through it. Is that fun?
Yeah, that makes sense. Totally.
All right, so again, I've got the command that I need to run. It's not a lot different than the command that we just ran. So Helm install, we've got a chart, which we'll look at, and then I'm providing a bunch of values, things like tenant ID, subscription ID, etc. There is some things in there that are a little sensitive, but I'll delete everything after this call. And all right, that's run. Cool. And now we'll talk about where we're going from here.
Okay.
So yeah, so we pulled it off. We were able to access secrets from Key Vault from our .NET app, but let's now extend that. Like, how can we do this using other languages and other types of applications? And so for that, we're going to look at something called the Container Storage Interface, or CSI driver for Azure. And this is just another, like we talked about extending the Kubernetes API. This is just another one of these kind of extension operator type packages for Kubernetes. And this one is not specific to Key Vault. In fact, I think if we look at these docs, I was looking at them last night. Yeah, so the CSI driver has built-in support for Azure Key Vault and then HashiCorp Vault. So not only is this thing generalized in that we can use it to access secrets for any language or anything that's running in any pod, we've now extended kind of the secret providers that we can access. So, and again, that's Key Vault and then HashiCorp Vault. And what it does, let me get back to here. So what it does is it accesses those secrets and then creates a volume that's attached to the pod. So basically just like a piece of disk that is attached to the pod that contains those secrets in it. Now you might ask yourself, though, like, hey, if I just have a file run on my pod that has the secrets, certainly I need to update my app to access that file. And that is true. And once we get this thing running, we'll actually go in and look at the file that's mounted that contains the secrets. But the CSI driver also supports synchronization with Kubernetes secrets. So it will do a couple things. It can mount the secrets as a volume in the pod, which might be the way you want to go, and in a lot of cases will be the way you want to go. But it will also create a Kubernetes secret, which I can then like mount as an environment variable inside my running app. So it gives you a lot of flexibility in how you access those secrets. Okay. And I think I'm going to back up actually a little bit and talk about, I forgot to mention one thing, or this is a good reminder of one thing about the last implementation. Yeah. So Kubernetes does have these things called secrets. Okay, get secret, which is kind of a secret store within inside of Kubernetes. But what we'll see is it's not super duper secure. Like if you have access, like if you gain access to a Kubernetes cluster, you can actually get the values of these secrets out. And we'll actually do that here in a moment. Okay. So one of the kind of benefits of the last method that we saw, now again, it's very specific to .NET, but it does not create secrets in Kubernetes. So it like circumnavigated the whole Kubernetes secret store engine and really just like Key Vault application. Okay. And CSI driver for Azure does give us some capability. We don't have to create secrets. Like I said, we can mount the secrets as a volume. But in my case, that would require me to change the application a little bit. Like, instruct the application to look for the volume, read the file, and bring the secret in. So kind of one workaround, and Kubernetes secrets are fine. You still have the ability to control access to your cluster. We're not just giving access to the cluster to our organization. Hopefully it should be finely controlled. So Kubernetes secrets are fine. I just wanted to call out that the big difference is that the last method didn't engage secrets at all. Right. In this case, I am going to use this extensibility of the CSI driver for Azure to synchronize with Kubernetes secrets. And then in that case, I will mount that secret as an environment variable in my running pod. And then going back to that .NET configuration manager, if you remember that kind of hierarchy, environment variables are one of those things. And I should consume that secret into an environment variable. My app can then consume that and then work.
Okay, that makes sense.
All right, cool. So let's go ahead and see. Again, we're going to look at a Helm chart and see. Now, this is very similar, so there's not a lot of difference. So we're going to spend a lot less time in YAML. This method still uses AD pod identities or Azure Active Directory pod identity. So we can see I'm creating the identity, I'm creating the binding, and then now we get into some of the CSI driver specific stuff. The first one is a secret provider class, which is, I won't go through all the YAML, but basically we're giving it the instructions like go out to this key vault. So we can actually see provider Azure. So this object type, I'm making some assumptions here, understands two different provider types, Azure and then HashiCorp Vault. Okay. And there might even be some others that aren't documented. I don't know. We're telling it to use pod identity, which is what we've already set up. We're giving it the key vault name, and then we're telling it specifically which secrets to go out and get. KV secret, which we saw before, and then a little bit of more information. Now, I talked about this works in two ways. We can mount volumes, or we can engage the Kubernetes secret store system. So this secret objects piece right here is purely optional. If we were to omit this, it would not create the Kubernetes secret and just mount the volume. In my case, I need the secret, so I have this in here. And I was kind of debating back and forth whether I would like update this thing and kind of like show before and after, but I decided to just smash it all together and walk through it. We then have a deployment that looks very similar to what we had before. Our AAD binding is set up. Same container image, same application. In this case, though, we are creating a volume, and we're using the CSI driver to kind of populate that volume. We're then mounting that volume at this location right here, so MNT secret store, but we're also creating an environment variable from the Key Vault, or I'm sorry, from the Kubernetes secret that was created from Key Vault. I don't necessarily need all these things, but I wanted to demonstrate the thing end to end. Yep. And we'll look at all of them. Even though we're not going to use the volume, we'll actually jump into the pod and see, just kind of visually inspect the volume. Okay. And then the rest of this is exactly the same. So I've got my service, so I can access it. I've got my ingress routes, and then I've got the integration with the Let's Encrypt cluster issuer. All right, so I ran everything already. So let's do kubectl get pods. This is my pod right here. Make sure that it's running. Oop. All right, so my application is running. Before we jump in there, though, let's go look at the secrets that were created. And I knew it was there because I saw it. And we can see KV secret. In fact, you can see that it's 7 minutes old. So that sounds about right. We ran that Helm chart about 7 minutes ago, or probably like 8 or 9 minutes ago. So we've created a new secret in Kubernetes, presumably from the information from Key Vault. And let's take a look. Like I said, you can actually get access to the values in these secrets. So I'll do kubectl get the name of the secret, output YAML. So we're really just getting like a representation of that object in YAML form. And as part of that, we can see KV secret, and then we've got this base 64 encoded value here. So I'm going to copy that out. I'm going to do echo that value, pipe that to base 64, and then -d for decode. And right there you can see hello JSON. Sweet. From Key Vault. So we've reached out to Key Vault and set that in. Although you can kind of see, you know, when you're being super duper security conscious, like, whoa, I've got access to Kubernetes and now I can see the values. But just something to keep in mind. But obviously we want to control access to the Kubernetes control plane and the availability to return these secrets, which you can do using Kubernetes role-based access control. We've got some cool, we're not showing it here, we've got some cool integration between Kubernetes role-based access control and Azure Active Directory. So you can literally create like security groups in Azure Active Directory and give them specific roles to your Kubernetes cluster. So one of those might be like, hey, you have access to this namespace, no secrets. Like I want to give you just enough access, but not enough access to do what we just did there,
Right.
which was to go look at sensitive data. All right, so we've validated that we've pulled the secret over. Now let's actually jump in and see that volume. So like I said, we're not using it, but for completeness, let's take a look at it. So I'm actually gonna create like a terminal session inside of the running pod. So I'm gonna do kubectl exec. I might get this wrong a couple times, we'll see. The name of the pod, and ooh, that's not what I wanted to do.
I do feel like there's a lot of copying and pasting in Kubernetes world.
Yeah, definitely. Okay. All right, cool. So we're inside of that running pod. I'll go up a level, ls, so we can see mnt. So I'll do cd. And in fact, that was defined in here somewhere. We defined where to mount the volume at.
Right.
Let's see here. Yeah, right here.
Secret store.
Yeah. And then if we look in here, there's a single file named kv secret. So it assumed that name from Key Vault. And I'll just cat this thing. Yep, and there it is. All right.
Very cool.
Hello, Jason from Key Vault. Presumably, though, I also have an environment variable in here. I think I can see this. Yep. So I just did echo $kv secret. Hello, Jason from Key Vault. So everything is in place. Let me get out, remove myself from this container. Go ahead and get our ingress path again, or our URL.
Neil, I know you're a music fan because we talk a lot about music. We have similar tastes. Lucas Nelson rocks. Do you like Blink 182?
Yeah, I mean, I grew up listening to all kinds of music, and yeah, I've seen them.
One of our viewers thinks that you have a striking resemblance to Tom DeLonge. And here you are on Microsoft Developer Twitch channel teaching everybody Kubernetes.
I'm flattered. Yeah, yeah, Blink 182.
They're okay. Cool. Yeah, I don't know.
Seen them several times. Like I grew up listening to that style. My music tastes have changed quite a bit as I age. But I
mean, you came from a skater background, right? And that's kind of that part of that culture.
Yeah, I grew up skateboarding, listening to punk rock music,
and jumping out of airplanes.
Yeah, jumping out of airplanes.
We'll talk about that on another show. But Neil has a lot of good stories about skydiving.
Yeah, don't do a whole lot of that these days. Since I had kids and stuff. But I mean, since we're on the topic, I have been enjoying mountain biking a lot lately.
Oh yeah.
So we've been, stuck at home just like everybody else, and there's this really cool bike park near my house called Doothy Hill here in near Seattle, Washington. So I've been doing a lot of that lately.
Very cool.
That has been a ton of fun.
Yeah, it's a good way to get out, get some exercise, and still not be around anybody.
Yeah, I don't know if you can see it, but I hit a tree the other day with my face. I actually momentarily thought I broke my jaw, but I'm okay.
Reach out and grab you as you were flying by, or did you wreck?
So these trails are set up. They're downhill trails with these wooden objects. They're just kind of like platforms, and they're wide, and they get kind of like balance beams. They get smaller and smaller and smaller.
Uh-huh.
And so there's this big long one that I've been hitting, and you kind of just have to I'm not even going fast. You're really just balancing on this thing. And yeah, like I'm focusing down and I look up, and it actually wasn't a tree. It was actually a fallen tree. So with like all the roots exposed, and yeah, I just looked up and hit it with my face. No fun.
Could have been way worse, I'm sure.
Yeah. I mean, like I said, I thought my jaw was broken, but I'm all good. But back to the demo. Hello, Jason from Key Vault. Nice. And that is it. I mean, we've, it looks very similar, but it's a very different implementation that is much more generalized. And as we saw, I can access the secret via the volume mount. I can access the secret via the environment variable that I created if I want to do that, and things look
Yeah,
good.
a couple different implementation options.
Yeah, and I think that's kind of it for my demonstration. I did pass over to you the link to this GitHub repo.
Yeah, I dropped that one in to the chat a little bit ago. It's the AAD pod identity one, right?
Yep.
Yep. So that's in there for everybody. Go check that out.
Um,
As well as there's another one that we were. What was that link? Do I have that one? Oh yeah, the stuff about Azure Key Vault configuration.
yep.
Yeah.
Yep. So
I'll
there's
put
a
that
lot
in there.
going on here. And like if anybody that's viewing is interested, like if you want to check this out, so we've got some Terraform configurations in here. If you just clone the repo and just run these two commands, it should stand up everything that we've seen. I'll kind of walk through it real
Yeah, we
quick.
got time. In fact, a quick time check. We're at about 19 minutes or so before we'll be wrapping it up. So
Okay.
we've got a little bit of time for sure. In fact, I was going to say, I know there was only so much we were going to be going over with Kubernetes, but if you got other things, we can talk about ARM, some of the tools that you were making there. But stepping through this would be also super helpful
Yeah,
for
I
a
think
lot
just
of the people
just in
on
case
here too.
anybody's interested, I'll just
Yeah,
kind of walk
absolutely.
through some of the stuff that's going on.
Let's do that.
So we had a variables file that just kind of controls the variables that we're putting into place, the resources that we're deploying. So we've got an AKS cluster, um, Azure Container Registry. So this is like if you've ever used like Docker Hub, this is just a place where you can push your container images to and then pull them from, creating the Key Vault itself, some access policies on the Key Vault. I just noticed these were here this morning. These aren't relevant. I'll actually probably pull these out. This is the SQL Server stuff. So most of this was adopted from a project that I was working on. It was for a customer, so I didn't bring that actual application over.
Mm-hmm.
I just forgot to remove the SQL Server stuff. But the big things is the AKS cluster, the container registry, the Key Vaults, bunch of identity configuration going on. And this is probably like the more complex part of this configuration is making sure that you've got the right identities in place and making sure that they have the right access that they need. Let's see here. And then finally, I'm using this new resource type that we have in Azure. Like if you want to talk about different things, this is totally cool.
Mm-hmm.
We've got a new resource type inside of Azure that allows you in an Azure deployment, so whether it's Terraform or an ARM template, kind of run some arbitrary code. So if we think about like infrastructure as code, like let's just take the Terraform provider for Azure or ARM templates. That's really about like control plane access. And what I mean by control plane, like we kind of think of Azure in two terms. We've got control plane, which is the things in which we have REST APIs for in Azure. So if I need to create a VM, we have a REST API for that. If I need to create a file inside of that VM, we don't expose that through an Azure API. So we consider that like a data plane operation. And traditionally, it's been very hard to kind of do some of those data plane operations during deployment because we just don't expose them in any way. So one of the ways we can get around this, and we've got, like I said, a new resource type to take care of this for us. And the resource type is called deployment resource. If you are interested, let's actually just look it up.
Okay.
Actually, it might be called deployment script resource. Yeah. So use deployment scripts. Nope, that's not it. Let's see. I know we have a good doc on it somewhere. Here is Sam Kogan's blog on it. But yeah, nope, that's not it either. Here, I know how to find it. Let me go in here. This is actually the resource type right here. So Microsoft.resources, deployment scripts. Well, here's the kind of the reference, the ARM template reference documentation on it. essentially what this resource type does is allows you to pass a script to an ARM deployment that will then run arbitrary code. And this is what I'm using to do things like, so I've got this file bootstrap.ps1. So like I'm connecting to the AKS cluster, configuring pod identity, installing Helm, installing the Nginx ingress controller, adding a DNS record, installing cert manager, and then the secret store CSI driver. Now I will call out, you want to be really, really careful with this type of stuff. One of the values of infrastructure as code and kind of redeployment or repeatable infrastructure is this concept of idempotency, meaning I've got this thing configured and I can deploy it. Yep. And then I can deploy it again, and it's only going to pick up the deltas or whatnot. Like as soon as you start adding arbitrary code, like this thing is no longer.
Then you got your snowflakes. Then
yeah, you totally got your snowflakes, and this is really helpful for like demo things like this. I mean, I can go delete this now. You can clone it, stand this all up, and you're going to have all the pieces there. But I would say, in doing this, you really risk kind of shifting away from that production readiness, and you really want to think about what you're putting into these deployment scripts. One last thing to address, potentially for the astute, for anybody that may have like clued in, I've got this configuration.tf file. So I've got a Terraform file here. But if you notice right here, I've actually got an ARM template inside of my Terraform file. Just wanted to call that out just in case anybody recognized that. What's going on here is that the Terraform provider for Azure just has not been, or at least it had not been a month or two ago, updated to support this resource type. And so Terraform gives you kind of this slick back door. Because the provider is an abstraction from the Azure REST APIs, it gives you this slick back door to allow you, like in situations like this, to add a template into your configuration. Cool. However, that also points out one of the big benefits of ARM templates, and we're kind of going on a side tangent here, if that's okay.
Yeah,
is that with ARM templates you do get like that day one support for, if it's in Azure, you can access it through an ARM template.
Yeah.
So that's all the Terraform stuff is in there. And you should be able to just clone this down, run these two commands, stand everything up. It's got the Helm charts. Oh yeah, one thing that I didn't mention is that when you do run them, there's this output.tf file, and it's going to return after the deployment a couple different commands. The first one is az AKS get credentials. This is going to get the context file so that you can access the AKS cluster. Next, you're going to log into the Azure Container Registry. The next one we're going to use something called az ACR build. This is really cool. With Docker, we can build container images using a Docker file. Docker file is just basically like a set of instructions on what you want to go into your container image. So I won't go through all of this, but we're saying like, hey, use this image as the base. So ASP.NET 3.0, and then, copy these applications into it, run .NET restore. It's just basically an automated way to build your container images.
Right.
We can run a command docker build to build the container image. However, Azure Container Registry also has this ability to build Docker files. And one of the benefits there is that in order for me to run Docker build, I must have Docker running on my system where I run that command. Using az ACR build actually just takes that Docker file and the context of which that Docker file is and ships that all off to Azure, and then does that build all up in Azure, creates the container image, and then stores it in the container registry. So like when you start thinking about things like, in I don't know if things have changed, but when I started playing around with this years ago, like one of the big issues with Docker build was particularly like in CI/CD pipelines, if that process might be running in a Docker container itself, there were issues running Docker inside of Docker, and you kind of got into this kind of like automation scenario where like, dang, my build's running in this container, but I then need to go build a container image, and I've like hit a technical limitation. This is one way to get around that.
Yeah, for sure.
Shipping everything off to Azure. And then finally, the last two things that it's going to output is the Helm install commands that bring together all of the information that needs to go into those Helm charts to run both of the samples that we looked at. So both the .NET integration with Key Vault and then the CSI store.
Great. Yeah, I was wondering where that was, when you ran that output command, where that was coming from.
Yep. And you just define that in a Terraform file, and you can see the type is output, so it's just going to output that stuff to the screen.
Yeah. Okay. Cool. Well, we've got about 10 minutes left. If anybody has any questions, definitely drop those into chat. In the time that we've got left, Neil, is there anything else you wanted to make people aware of, or stuff you've been working on, things you want to let people know about? What else is going on?
Yeah, let me just go ahead and plug the VS Code extension for ARM. So I showing off Terraform here. It just so happened that the project that I was working on with a customer, Terraform was their excuse me, infrastructure automation tool of choice. I happen to be a huge fan of ARM templates. And this is kind of the role that I'm just rolling out of, which I enjoyed a ton. I just wanted to do more engineering.
Yeah.
But I want to plug AKS, or the Azure Resource Manager tools for VS Code. So this is an extension for writing ARM templates in VS Code. Really, really great extension, has a lot of capabilities, really great engineering team, and a lot of motivation and kind of improving the experience around authoring ARM templates. And I mean, in my opinion, not just because I worked on it, but this is like, bar none, the best experience that you're going to get
Absolutely.
For authoring ARM templates. I'll got a couple minutes here. I'll detail a couple things about it and like why it's so cool.
Mm-hmm.
So an Azure Resource Manager template, is just kind of a JSON looking document. There's a lot that can go wrong. Syntactically, you need to make sure that you've got your braces and your commas in the right places. So we help with that.
Right.
So that's cool. But in my opinion, where it really shines is, so you've got the complexities of JSON and the language, but you also have the complexities of Azure.
Mm-hmm.
So, it's not just about like, that looks complex, but like if I'm deploying a VM, what are all the different properties that I can put on that VM for deployment? And how do I know that they're right? And one of the really cool things about this extension is it's not just about the syntax of the ARM template, but we actually consume Azure schemas. So for every resource in Azure, we've got REST APIs, and we've got Swagger that kind of defines how you would make requests against those APIs. We take it even further, and we generate Azure JSON schemas from that Swagger that details, like, for any given resource, here's all the available properties and the values, and are the properties required? Are they optional? And this extension consumes those schemas and kind of helps you not only ensure that your syntax is correct, but that you're using the right properties and values. So like, for instance, if I got a storage account of like, and the kind is storage v2, but I mess it up and I do like storage v3, this extension is going to like let you know, like, hey, that's actually not a valid storage type.
Yeah.
Like, syntactically, the template is correct, but if you deploy that, it's going to come back and say you must use a valid storage type. And not only does the extension flag that, but it will also provide you with all the available values.
Mm-hmm.
So yeah, just plugging this thing, it's super awesome. I really, really, really enjoyed working on it, and I'm super excited to see where it goes from here.
I totally agree. And when you introduced it to me, I think, well, because this has been around before you were working on the team, right?
Yeah.
And like, it totally changed my mentality on ARM templates. I was like, I don't know, like, it wasn't something I'd done with, or messed with a whole lot previously, and I was struggling with before I knew about this plugin, inside VS Code, trying to author my own files, my own templates. And then the method was that once I had it how I thought it was supposed to be, I just highlight it all, copy it, and then go into Azure and then deploy from a custom template. And it's not until then that I found that I had syntax errors, or that I found that something was wrong, or, and now through this plugin, not only does it like have the guardrails to tell you, no, your syntax is wrong, also that's not a valid thing, and just like walk you through it, doesn't it also have some sort of preview thing or scenario where it'll like run through your template and say, yeah, that's good, and here's what it will create, right? Give you like
yeah. There is a tool for ARM templates called What If, very similar to Terraform Plan, which basically it looks at your ARM template, it looks at what's been deployed in Azure, and kind of tells you what the difference is going to be if you were to like rerun the deployment. Is that what you're referring to?
Yeah, I think that's exactly what it was the what if, because so many times I was creating a template and it had some large, or I shouldn't say large, but some resource that took a while to deploy. And so I'd have to, go do something else for 20 minutes only to come back to it later and find out that it wasn't right. And so you can at least like have this time saver type of thing.
Absolutely.
Yeah, it's great.
And I think, if I can get just one more minute, I'll kind of plug some of the stuff I'm working on now. And that is this AKS Secure Baseline comes from my team. I mean, looks like I'm the last person to commit anything to it. And we actually have a doc on docs.microsoft.com that walks through kind of a lot of the implementations, although I did want to bring up the GitHub repo because this is where you can deploy it from. But one of the things that my new team does is we really look at like end-to-end scenarios and production readiness of scenarios. And so one of the things that we're working on is this kind of productionist like recommendations on how you would run AKS in production. And it's pretty funny. I just joined the team recently, and I started going through this doc, and like kind of what had occurred to me is like, man, I've deployed hundreds of AKS clusters, and there was still a lot for me to learn here, and kind of like how I would want to make this thing secure, how I want to, access it, how I want to kind of delineate the networks and manage the different like places in which my cluster is exposed, et cetera, et cetera. Yeah. So definitely, if you're going to be running Azure Kubernetes Service in production, I would recommend taking a look at AKS Secure Baseline. The other place we can find this is if we go to AKS Docs under Concepts, and then I believe it's under Best Practices, Baseline Architecture for an AKS Cluster. And this doc walks through some of the decisions that were made. And this was a big effort, not just my team, but AKS product team, field teams that have actually been out with our customers deploying AKS into production environments. And we've really kind of taken all of that information and distilled it down into what we call a reference architecture that really just gives you kind of a view and some recommendations on how you should think about running AKS, Azure Kubernetes Service, in production, beyond just like, AZ AKS create, really kind of get down to like the different networks and subnets that you might want to create, things like pod identity, integrating with Azure Active Directory, looking at role-based access control and how that works. And there's just a bunch of really good stuff in here that I would really, really recommend it for any kind of production workload.
Yeah, there's actually, as we were preparing, I'm going to come back to the side-by-side here so we can say goodbye. As I was preparing for today, I was looking at all the different docs that we have out there on Kubernetes, and I'll add all that to the show notes. So for those of you who haven't been watching that All Around Azure before, after the live stream, some point we'll put the video up on YouTube and eventually over at allaroundazure.com as well. But I found in my research also that there's a ton of really good Learn modules. And I just dropped one into chat for everybody to go check out. If you're not familiar with Learn, it's just our free online learning courses. It's all gamified. It's pretty fun. And there's a ton of good stuff on there. So anyway, in the last like 30 seconds or so that we have, Neil, this has been so fun. I hope we can do it again. It's good to see you again. Okay. Welcome back to the DevRel group. Excited to have you back on the team, team-ish, I guess. We're not really on the same team, but we're doing similar stuff. So
we're all one big team. Sure.
Yeah, exactly. And yeah, thank you to everybody who's joined us on the stream. It's been awesome with the questions. We had one other question there about how much do you need to know about K8s to get started with the Azure Kubernetes Service. A kind of difficult question to, I guess, really zero in, but I would say check out the docs, check out the Learn modules. There's a lot of good stuff on there, and it should provide you with a sandbox and everything to really get your hands on there and start playing with stuff. So anyway, thanks again, Neil, and thank you everybody that's joined us. And I'll be back again on Thursday with my good friend Jeremiah Dooley, and I hope to see somebody then and in the future. So thank you so much. We'll talk to you later. Bye.
Thanks, Jason.
See you, Neil.